Okay, so one of the reasons why we learn about determinants is because they help us find the inverse of a matrix. They also help us do other things, like solve the matrix by using Cramer's rule. But for now, we could just look at how we use a determinant to find the inverse of a matrix. And why is a matrix inverse of a matrix important? Well, we'll see later that there's no such thing as matrix division. So like if you had an equation like this, like 2x equals 8, and you wanted to see like what value of x made this true, you could divide both sides by 2, and you get x is 4. Now, if that was the same situation, but it was matrices, so a matrix A that we know times a matrix X that we don't know equals a matrix B that we know, how would we figure out what X is? How would we isolate it? Well, instead of dividing by matrix A, we would multiply both sides by the inverse of matrix A, and that will cancel out that matrix, and we could figure out what matrix X would be. Okay, so that's why we're learning about inverses. It's to solve matrix equations. Now, inverses you could do on the calculator, but you should know how to find it by hand for a 2 by 2. Alright, it is useful to know. Okay, so if this is matrix A, where A, B, C, D are the numbers in those positions, so if you look down at this matrix A would be 1, B would be 2, C would be 3, D would be 4. Okay, the inverse is going to be 1 over the determinant of A, okay, scalar multiplied by this matrix. And if you look at the original matrix, you could see that you just switch A and D, so flip-flop these two, and then negate B and C. Alright, so how would that look down here? Okay, well, first we would have to find the determinant. So the determinant of A would equal 4 minus 6, because it's 1 times 4 minus 2 times 3. So 1 over the determinant of A would be 1 over negative 1/2. Now, we're going to switch A and D, so 4 and 1, and then negate B and C. So, this is the inverse of matrix A. Alright, and we can simplify it further by like distributing the 1/2, or the negative 1/2 if we wanted to, and we get negative 2, 1, 3 over 2, and then negative 1/2 if we just distributed this negative 1/2 to all of these. Okay, now why is an inverse useful? Well, I just mentioned it. It helps us get rid of a matrix if we're trying to like solve a matrix equation. And the reason why that works is because in math, anytime you multiply something by its inverse, you get the identity. Alright? And the identity matrix is this matrix, where I'm going to pause this and refix that for a second. Okay, sorry about that. Now I got it drawn the way I want. So real quick, so anytime you do like 3x divided by 3, they cancel out because 3 over 3 is the multiplicative identity, 1, which means 1 times anything is itself. Identity means you apply that and it doesn't change. So like the identity to adding 5 would be subtracting 5. Sorry, the inverse of adding 5 would be subtracting 5, because together they give you the additive identity. 0 plus anything is itself. So the matrix, the identity matrix is going to be this, 1, 0, 0, 1. That's for a 2 by 2 matrix, because this matrix times anything is going to be itself. Alright, and we'll see that more later on. So now look what happens when I take matrix A and multiply it by its inverse. So I get 1 times negative 2 is negative 2, and then 2 times 3/2 is 3. Add those together and we get 1. Okay, 1 times 1 is 1, plus 2 times negative 1/2 would be negative 1. Added together and we get 0. 3 times negative 2 is negative 6, plus 4 times 3/2 is positive 6, so we get a 0. Alright, 3 times 1 is 3, plus 4 times negative 1/2 would simplify to 1. Okay, so any matrix times itself is the identity matrix, and then any matrix times the identity matrix is itself. Alright, and we could just check that real quick by doing matrix A times the identity matrix, since we're on the subject. Okay, we get 1 times 1 is 1. Alright, 2 times 0 is 0. Alright, 1 times 0 is 0. 2 times 1 is 2. 3 times 1 is 3, plus 4 times 0 is 3. 3 times 0 is 0, plus 4 times 1 is 4.